And that means that we have to embrace, oops, something happened there. It means we have to embrace technology shifts. And manufacturing is in front of more technology shifts than it ever had in front of it. And that's true for most activities. Technology keeps accelerating. I heard that we have a number of representatives from the design science area, so I will make a few reflections later on, but I will say immediately, just as an interesting reflection. In the science area, scientists that I meet tend to say that our cumulative knowledge now doubles around every 18 months. That means that over the coming 18 months, we will learn as much new things as we have learned at this point in time throughout history of mankind. That is pretty amazing. In design science, it's 5 years, roughly, for the doubling of knowledge. Now, this is an interesting effect because it actually tells you about not walking at the same step. It's out of step. So there's an issue about how do you keep up to breast with these things as you do it. It has implications if you're an engineer, how long your knowledge is up to date. You know, if you get a job in a company today, that means you probably, if you are completely on top of your game when you get the job, if you do not pick up any more language, you are completely useless probably 18 months from now. That's a scary thought. And it puts a lot of emphasis on further education and on skill development. It also means that these opportunities that are able out there, they are enormous number of opportunities, but we have to understand that they exist, and that means keeping on top of what's happening. And in technology, this is enormous opportunities. Material science is exploding, biotechnology is exploding, and this will have implications for all of us, positive and negative. In manufacturing, we see the impact of digital manufacturing. Right? We see the issue about being able to do complete constructions, testing, and design purely on the computer. I don't need to produce anything physically on the process up until they have the final object ready. And that means that when I have the final object ready, I can also design digitally the layout of the manufacturing system that is going to produce this final product that I have designed. At this point, nothing exists in the real world. It all exists digitally. Then I can verify that it is the right place by using augmented reality. So I can look through these glasses and see things in my glasses that don't exist in real life. So I can verify that components will fit together and it will look right where it is. And then I can ensure that I redesign the manufacturing tools that are needed to do this if it isn't already available on the market. And that means that I can sit here as a component supplier in an advanced supply chain, defense, automotive. And I can then do all these things digitally. At the end of the day, I have a file ready for the machine tool that I transmit to my customer in the supply chain who is located somewhere else. Maybe they sit in Malaysia, opposite the road from Proton. And at that point, they receive my digital file. It goes straight into their machine tools. The machine tools first produce the modification to the existing machine tools. Then they hook those up. And then they run the second file, which produces the end component that then is taken physically and carried across the road to Proton, where it's put into manufacturing. This is all still manufacturing. It's just that it operates in virtual space. And we see a rapid move to this area with a number of consequences. Positively, transportation costs have just gone away. It doesn't matter how far away you are. It doesn't cost anything more to sit here than to sit next door. Right? So that whole thing just went away. The other positive thing is that there are many more opportunities to do things than you did before. You can charge for storing all designs and put into use anytime you want. There's lots of opportunities for further businesses. The negative things, of course, are it requires skills. If you don't have these skills, you can't do this. And it requires investments. If you don't have the money to invest in these things, you can't do it. So there are always pros and cons about these things, but that's true about any market. And the speed at which this happens depends a little bit on the industry you're in. And for some of you, it's going to be the digitalization which is going to be a challenge. For others, it's going to be biotechnology. If you're in the food industry, one of the ways you can add value is by working around things like functional foods and other things, food that enhances the well-being of people. And we can do a lot of things in biotechnology now that we couldn't a short time ago, and we will be able to do even more shortly. The time is here when we can write DNA as we write software. That means we can design bacteria that did not exist before, synthetic biology. And we can put these bacteria to very efficient use in production processes that we previously couldn't do that way. This will dramatically change industries. For example, high-value chemical is changing as we speak. Almost no pharmaceuticals in the future will be made using the chemical approach we used to do. It's all going to using biotechnology. And we go into long molecules rather than small molecules. One of your biggest biotechnology companies is BHP Billiton. And the reason for that is that within a couple of years, 25% of all copper, for example, will be extracted using biotechnology principle because it's more cost efficient, more effective than using traditional mining techniques. That means you need biologists in the mining business. So there is a constant change and constant technology development in all these areas. And again, these things put a lot of challenges to policymakers because it means that historical data becomes less relevant as the speed of development increases. Historic distinctions and definitions becomes less relevant as the fluidity of these things mixes up the boundaries of what we do. And that means, of course, that we have problems knowing the facts on which we make decisions. The Economists wrote in an article on the 10th of January last year, and I quote, "In practice, there is no clear line between what counts as service and what has been made. The distinction owes more to government statisticians than anything else." Right? And the Department of Trade and Industry in the UK stated in one of their recommendation reports, a short quote, "It is preferable to look at service activities as opposed to service sectors." In other words, we have to rethink on the policy side these type of areas. And when we look at these things and take into account this more general definition of manufacturing, the curve probably looks like that. Manufacturing is actually a growing part of most advanced economies rather than a declining part. It's just that it changes form and shape, and it hence fools our statisticians. And this is a very important message for policymaking. You here have a great manufacturing heritage. You have a great manufacturing industry. A lot of your companies have been or are part of two of the most demanding value chains you can have, which is automotive and defense. That means you have enormous skills. You have enormous capability. The question becomes, where else can that capability be put to good use? And to underline that importance, let me show some statistics. You may or may not read this. If you can't read it, look at the colors. I picked a few countries here. Okay? Australia marked in black, and then Austria, Canada, Denmark, Finland, Germany, Japan, Spain, Sweden, Switzerland, UK, and US. And I've taken a set of interesting statistics that you can look at from just looking at how they view manufacturing in that type of area. For example, what share of the economy comes from industry in value adding? And you can see the green ones are the high ones, the red ones are the low ones, and the white ones are in the middle. So the difference isn't that big, but it varies, from about 33% down to about 22%, I think it is in the US. You can look at the manufactured value produced per capita. That's an interesting measure of whether you have high value manufacturing or low value manufacturing, and an issue. Australia sits at about $11,000 per capita, Switzerland at $43,000 per capita. Now, put that in perspective. I sometimes hear now, the Australian dollar is going up, it's such a pain, our margins are being eradicated. I can understand the statement. Now let's think of Switzerland for a moment. It is the economy with the highest continually value increasing currency. Since the 70s, the currency has multiplied by 7 in value. By 7. Still, manufacturing is the largest single sector in the economy, contributing 2 to 3 times the contribution of financial services. And it's a high value added, extremely successful manufacturing industry, contributing $43,000, 4 times the equivalent of Australia's contribution per capita. How can they do that? And anybody who knows, been in Switzerland knows it's not a low-cost country, right? Buy a steak, you get a heart attack when you get the bill. That's one of those things, all right? And buy the wine, you get a heart attack too, in spite of the quality being substantially inferior to your wine. So that's my issue. So, they do something right. They do something very right. They do a number of things. Firstly, they manage their product portfolios in companies and the company portfolio from a national perspective. When you reach the point that you are no longer competitive, you get out of it immediately, preferably before. You do not try to compete with things you can't compete. It is meaningless. Sell it to the Chinese. That's what we did with Volvo in Sweden, right? You know that Volvo is, we used to have 2 car companies in Sweden that make cars. We still have a few truck companies. We used to have 2 car companies in Sweden, Saab and Volvo. You know, they were Swedish. Now we have 2 of them in Sweden, but they are not Swedish. Volvo is Chinese and Saab is Dutch, with Russian money behind it, but that's another issue. So, you know, get out of it. It's not your problem any longer, right? Yeah, it's one of those things. The second thing they do is they keep on top of technological development. They have leading edge universities in close cooperation with industry producing useful things. Where would you have gone if I had come to you with this proposal? I want you to invest in my venture. We are a landlocked country, but we're going to build from scratch, white sheet of paper, a sailing boat. And it's going to win America's Cup. Would you put my money with me? Probably not. But they did it. And it was managed by a university in cooperation with industry, producing new technologies, designing new ways of doing, resulting in a vessel that had to be helicopter lifted to the sea to partake in the race. And it won. That means you put new technology to use in a profitable way early on. That means the companies are aware of this technology and they know how to play with it. And it means that the employees in the organization are extraordinarily well educated and continuously can be educated to put this to use. This can be done. QED, as we say in Latin, right? R&D expenditure as percentage of GDP. Well, down here, Sweden hovers around 4%. Australia is around 2%. And out of the Swedish contribution, over 80% is private sector. This is not government handing out money to universities. Over 80% is private sector. In one of our universities, which is world leader in its field, for those of you in medical science will know it, is Karolinska Institutet, right? It's the world leading medical research institute. It has 43% of its budget from public sector in Sweden, the rest comes from private and other places abroad. They have 3,800 staff, roughly, of which 80% are academic, 20% is administrative. They produce close to 5,000 peer-reviewed articles a year. That's more than 1 per academic staff. They have 1,700 undergraduate students. That's 2 academic staff per student. Zurich Technische Hochschule, so the technical university in Zurich, one of Europe's leading technical university, has 4 academic staff per student. In order to produce high-quality graduate that can go straight into industry and create immediate value under these boundary conditions. How many academic staff do you have per student? R&D is critical, but it's private sector-led R&D. ICT investments share of total industry investment. This tells you how industry prepares itself for the shift to the digital economy. So what amount is it? In Australia, it's about 13%. In Sweden, it's 25%. In the US, it's 26%. Right? That's twice again of investing into important issues. And this is not issues in building telephone lines or networks. That's already done because these places have 84% of the population connected up. And look, you can say these are small countries. That may be fair. Sweden is 2,000 kilometers from north to south, and an area where most people live in the cities, but we still have to draw very long lines across big forested areas. You have mining as your endowment. We have people with forests as endowments. And it's more difficult to dig something through a forest than it is to dig through a desert, because you have roots and other horrible things in the way, right? That's it. But it's another activity. Expected growth rate 2010, using the latest OECD data. Sweden grew last year with 4.4%. Australia growing very well, 3.3%. Right? Japan 3.7%, Germany 3.5%. These are the top growing. But if you remove the endowments, in other words, the mining issues, what is your growth? That's an interesting question. These are high-growing, export-oriented economies. They do very well, but they export things that are produced. In other words, manufacturing.